This is PSpice simulation tutorial series. In this video, we will use a simple RC circuit to demonstrate how to do performance analysis and plot for rise time goal function. So let's get started. In the first step, we are going to create an RC circuit project. To do that, we'll open OrCAD Capture from Cadence program menu, select the license file and click on OK button. Once the OrCAD Capture is ready, we are going to create a new project. To do that, we'll go to File, New, Project. We are going to name it Performance Analysis and we are going to save it on desktop. Open the folder and click over Select Folder button. Make sure you have selected Enable PSpice Simulation and click on OK. In the next step, it is asked us to use a template or you want to create a blank project. In our case, we'll select Create a Blank Project and click over OK. Once the project has been created, we are going to place components. To do that, we'll go to Place, select Components, and PSpice component library window will open. Now here we are going to place 4 components: resistor, capacitor, VDC, and parameters. So I'm going to do that quickly. Once all the components have been placed on OrCAD Capture canvas, we are going to create a circuit, which will be a simple RC circuit. So first we are going to place a DC source here. Then there will be a resistor, which is 1K. To rotate the component, we'll select the component and press R on our keyboard. We'll place it here. Now to connect these components, we'll press W on our keyboard and make the connections. Next, we are going to place ground. So click over this Place Ground button, select 0 cap sim and click over OK. In the next step, we are going to add parameters. To do that, we'll double click over parameters, click over New Property, and our parameter will be CVal. Enter its value to 1 nanofarad. Click over Apply and Cancel. So we have added this parameter. We'll select the parameter, right click, go to Display, make visible its name and value and click over OK button. Save the parameter. Here we go. Now we are going to replace the value with CVal. So double click here and we have to place it in curly brackets and click over OK. Let's place it somewhere here. Then we are going to zoom fit this entire circuit. Here we go. Right click and mode. In the next step, we are going to create a new simulation profile. To do that, we'll go to New Simulation Profile button. Let's name it Performance Analysis and click over Create button. Now in this simulation setting window, make sure you have selected Analysis Type Transient Analysis. We are going to run this simulation for 10 microseconds. Then we are going to select Parametric Sweep, which will be CVal in our case. So let's enter CVal here. Then we are going to enter start, end and increment values. So start value will be 1 nanofarad, end will be 10 nanofarad and increment of 1 nanofarad. So there will be 10 iteration of this parametric sweep. Then we'll click over Apply and OK. Now in the next step, we are going to change the properties of this C1 capacitor. To do that, we'll double click over C1 capacitor and here you will find one attribute which is IC. So we want to make it 0. So let's select 0 here. Now why we are doing it? So here we are setting initial value of a capacitor. So it will see open circuit at the very beginning of the simulation. Alright. Then we'll click Save and close the property edit. In the next step, we are going to run the analysis. To do that, we'll click over Run Simulation. Now it is asking you want to go for all the 10 iterations or you want to run the simulation for specific values. We will select all and click over OK button. Here we go. So the simulation is successfully done. Now in the next step, we are going to plot for V output. To do that, we are going to add trace button. And from here, we'll select the second pin of output capacitor. If you want, you can add the net label there and then it will be visible here. So in our case, we know that it's second pin of capacitor and click over OK button. So here we go. We have the parametric sweep of the V output at different capacitance value starting from 0 to 10 microseconds. So this is the transient analysis. Now in the next step, we are going to do the performance analysis of the RC filter. To do that, we'll go to Trace and from here select Performance Analysis. We'll go with these default values, go to Wizard. Now here we have the table of all the measurements which we can select for performance analysis. In our case, we are going to do it for rise time with no overshoot. So let's scroll down. Here we go. So here we have this rise time no overshoot. If you want, you can read what this function or measurement will do, and then we'll click over next button. Now here we have to select the trace we wanted to add here. So that will be the second pin of capacitor. We'll select it. So here we go. Here we have the performance analysis of this RC filter for rise time with no overshoot. All right. And here we have the correct capacitance value at the output side. Then we'll click over next. And we have both the plots here. So that's it for this video. In the next video, we will learn how to create a measurement function that measures the pulse width of output of a buffer circuit. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.